Everyone is there?
Yeah, I think almost everyone.
Almost everyone. Okay, hello everyone. Before started this class session, we have a comment for you. Remember that I told you at the beginning that everything you are doing on the server, we know about your activities. We know when you log. We know when you unlock, and so on. So we are follow you behind to see whether everything is going well for each student. And then for the half of the class, everything seems everything seems okay. You analyze your fragment, all of the items are filled, and so on. But for the remaining part of the class, it's not going as well as we predicted. Okay, some of you spend 8 days or 25 days without connected. And even if you are connected, some of you spend only I don't know 8 hours on an autoton. So the goal is not to spend a lot of, but to to work on it. 8 hours is not probably enough. So once again, my advice, since the time is running, my advice is to really take time to make your annotation on Annotaton. Now we have 13 days remaining. I hope that it will be enough for all of the students to fulfill the annotation. Okay? So that was my advice. If you want to make everything fine and or to do all of your annotation before the 21 of March. So, any other comment?
No, I don't have any comment for them. So that will good help on the analysis.
Yeah. So today we are going to continue. We have only 2 hours. So those 2 hours will be you can ask us every session. You share your screen. If you have any question, we will be there to answer it. And I don't know. It's a practical exercise, so do not really hesitate to share your screen, to ask a question, and then we will see. Okay?
Yeah, I think it's better if you want to share the work with us, so we can have like the quick comment for you if you want.
And that comment can be also useful for all of the class. Okay.
Yeah.
It's coming. Okay.
Let's see. Yeah, so first, my in group is Clostridia and my out group is Bacilli.
Okay.
And I found a tree on the internet. So I found the tree in the Vermicultura, and they have a distinct group of Clostridia and a distinct group of Bacilli.
Yes.
And I don't know how to compare this tree applied to my tree.
But in fact, here you have this is the tree of. Can you show me the title? It should be something related to the tree of Firmicute.
Yeah, it's
an update of reference phylogeny of Firmicute. Okay, so it means that if you take that tree on the right, and then you try to draw the topology of your tree, you will have Clostridia, and then followed by bacilli, and then followed by what it's written Firmicute bacterium, and followed by a big group of all of those branches, Firmicute, all of them are Firmicute bacterium, and so on. So you will have three nodes, three big nodes. Can you go up a little bit? Ah, yes. You have your art group, and then you have, yes, you will have the, so my coming back, I tell you again, to draw the topology of the Firmicute, you have a big triangle of Clostridia. Are you agree with me?
Yes.
And then if you go down, you will have another group of bacilli. And if you go down again, you will have another group of all of the other Firmicute bacterium. This big group share a node with bacilli. Okay?
Yes.
So those three main groups, okay, are separated in your reference tree, in this reference tree or tree of life.
Yes.
So you should find in your tree. So if you go back now in your tree,
I have a
you
picture.
should normally find Clostridia separated from bacilli in your tree.
Yes.
If you do not find that, it means that your reference tree do not follow your own tree.
Yeah.
Okay?
My tree does not follow the tree of life.
Okay. This is a question or it's a comment about your tree?
Is a question.
Ah, so to see that, you should also make the topology of your tree. Remember, I told you when you get a tree, you should make the topology in order to create monophylogenomic group, to find them. And if your in-group is Clostridia, normally you should find them, you should find a topology with your in-group and with your out-group, if everything is fine. And in that case, your tree follow your reference tree or your follow your reference tree. Okay?
Yes. Yes.
If not, your analysis or your comment on Annotaton will be, my tree do not follow the tree of life.
Yes. Okay.
Okay?
So can you comment also on the topology of my tree? I also
Okay. So what are, so it's with your lift, it's very hard to know who is who here. Where is how you mark your in group and how you mark your out group here?
Yes. So the cross treaty, I will start with the BFC here. BFC.
Okay.
And the bacilli is a BFB.
Okay. But so it's okay, but you should find something that is more clear. I don't know how you get that tree with BFCC, and normally you should have bacteria, Firmicute written, Clostridia, completely written name, instead of BFCCCC and so on.
Yes.
Yeah, it should be.
I will write phylogen, so it name in.
Okay, it means that in your legend, you should be clear about that. You should write a small legend to specify that BFC is for Clostridia, and then BFB is for Bacilli. Okay,
Yeah.
so I'm looking of them. So if I started on the top, you have BFC, Clostridia, and then you have one BFB, BFBLSS, that one. So it means that all of the branches on the top can be considered as, yes, those one can be considered as the monophyletic group.
Yes.
Okay? But a monophyletic group of Clostridia.
I agree.
And then I go down, we have BFB, BFBBBBB, and then those two branches cannot be considered as a monophyletic group. Okay?
No.
No, not that. In that, you go a little bit up. Those one.
Yes.
And then I go down, I have BFCCCO, and then BFCCCC1. They are a member of Clostridia, but they cannot be considered as a monophyletic group because we have only two branches. Okay?
Yes.
And then I go down, BFBBBP, BFBBBP-B1 again. I have BFBBBP. Yes, those. And then I have four like that. They can be considered as a monophyletic group at the node with those four. Okay? It's a monophyletic group of Bacilli. It's okay? No, you don't follow me.
Here.
Yes, those four can be considered as a monophyletic group of Bacilli. And then I go down, you have all of them, from BBCCO until BBCCO FU F2. All of them are members of Clostridia. So at the node shared by that node, all of them can be considered, all of these branches, all of those sequence can be considered as, can be grouped as a monophyletic group of Clostridia. Okay? And then you have the last one here. Those are from Bacilli, another monophyletic group.
Yes, I agree. And
as you can see, you do not have here a clear separation between between Bacilli and Firmicute, and Clostridia,
yes,
as in your reference tree. If you go back on the reference tree, you see that there is a clear separation between Clostridia and Bacilli. Okay?
Yes.
If you go back on your tree, you see that there is not a clear separation, since you have on the top some member of Bacilli, and then if you go down a little bit, another set of member of Bacilli. So there is not a clear separation between them, between those two big groups of Firmicute. Okay? Hello?
Yes, yes.
Yes. And then now where are your own sequence? It's HMP, that one. That one emerge inside a monophyletic group of Clostridia.
Yes.
So they are member, so they belong to Clostridia.
Yes. Thank you.
Okay?
I agree. Yes.
Yeah. So now if you go back on your annotaton page, yes, that one. Why did you choose to work at the level of class?
Because the Clostridia has the minimum value, and it also has a large result. So I
But
pick as
you can also choose as an in-group Clostridiales and as the out-group Thermoaneurobacteriales, something like that.
yeah.
Yes, and then you will have a more precise origin of your fragment.
I try this in order.
Yes.
My sequence, my RIF is outside of the our group. It had its own branch, so I moved into class.
Okay, and then did you keep your the trees at the order level? I mean, did you put it in annotaton to explain why you move from order to class level?
No,
it's really important. Otherwise, during the evaluation, you see, during the evaluation, you are not close of me to tell me that I did that before, but I should have a proof, a scientific proof about that.
Yes.
You see? So you start with order, and then you find that your open reading frame emerge out of Clostridiales, and then you keep the trees to have a scientific proof of that, and then you move to class.
Yes, I understand. I will add it later.
Okay, it's important.
Yes.
Okay. Any other questions?
Can you explain how to use the note, the word note plate French?
I didn't catch what you said. The word.
Can you explain the difference when we use the vocabulary as the note or the plate, the branch when we describe the tree?
No, I didn't understand. What is? Did you catch the question, Tam? I didn't.
Just to describe the tree, the topology, so we can use something like the note.
I think she want to ask about the vocabulary, like the things she can put in the report. You know, that's the notes between the group or like the.
About the vocabulary, you have a tree. In the tree, you have branches. You know what is a branches in the trees. You have note. You know what is a note in the tree. So you have leaf. This is what you have. The name, the BFCCC of each of your tree. This is a leaf, okay. And then from that, you can, to draw the topology, you should find in the phylogenetic way to get what we call the topology. It's a group. You should redraw your tree in order to highlight the main group of your tree. Okay? And then one of the main group of your tree it's called monophyletic group. And as we see during the lecture, a monophyletic group, it's the group in which you have at least 3 members of the same group, depending on the level you are. Okay, it's clear. You choose the level you are working, and then you should find monophyletic group based on the taxonomic level in which you are working. So you should have at least 3 members. And if you have more than 3 members, you should have at least 90% of the member of your monocycle belong to the same group.
Yes. Okay.
It's okay? Do you need more? I don't know exactly what you...
Yeah. Okay. In terms of writing the report, can you suggest us some?
Can you go back on Annotaton?
Yeah.
And then the 3 item, you click on the 3, you go to the 3. Yes. No, it was the rule book. Sorry. Yes, you have. Sorry, you have the rule book. You already got it. You have it in your Annotaton. In fact, you have it. Can you go back? Can you go down until the rule book? You have the rule book of your tree. Where is it? Yes, that one. You have not really the rule book about the tree.
Yeah.
No, and then you go down. You go down. Yes, that part. So the first thing you need to do, as I tell you during the lecture, is you need to make the topology of your tree. You describe the topology of each tree. Okay? And then you describe which are the monophyletic group you observe in your tree. That is clear.
Yes.
So do the 2 independent trees describe the same evolutionary history? It only means to compare the topology of your 2 trees. As you compare the topology of your tree, again the topology of the reference tree. Okay? It's in the same way. Okay? And then, do you have incoherency in your tree? Incoherency means that did you find something that is related to lateral gene transfer or horizontal gene transfer? Maybe yes, maybe no. Don't. I mean, don't. If you have horizontal gene transfer, it's okay. But if you don't have horizontal gene transfer in your tree, don't be sad or don't be afraid about that. It's not a problem. Okay? But you should try to identify them.
Yes.
Yes. That is only so. And then you move to the coherence of your tree with reference tree or with the tree of life. So you find a tree of life in the paper, in the scientific paper. Some of the students will maybe compare the tree against the tree of life from Life Map. If you make Google Life Map France, you get a website in which you have something related to the tree of life in prokaryotes, in eukaryotes, in fact, archaea, and then in bacteria too. It's okay. And once again, did you find, if you find discrepancy between your reference tree and your own tree, you should write about that.
Discrepancy is a difference.
Yes, or something that is not clear. In your case, what's if you go back on your trees, your own tree? So in this tree, the discrepancy should be from the top to down. And started from the top. The first two BFB, you found them? Yes, that is a discrepancy compared to the reference tree. Another discrepancy should be the four BFB, a little bit down. Yes, that is another kind of discrepancy. But the monophyletic clade down, completely down, that is not the discrepancy.
Yes, yes.
If everything was found, you should find all of the 6 sequence of the top down. You see what I mean?
Then
Yes. In that case, everything is fine. In that case, your tree follow the life tree or the reference tree. It's okay?
yes.
So that's what it's called discrepancy. And then if you go back on the rule book where we were just before, okay, and then your in or out group correctly separated. In your case, what did you think about that? Are the in or out group correctly separated?
Not, no.
No, the answer is no, due to the discrepancy. Okay?
Yes.
Yeah. And then the last part number 3, predict the most likely taxonomic origin of your metagenomic groups. We already talked about that. In which monophyletic clade your sequence emerge. Okay? Propose a hypothetical taxonomic classification. It's the same thing. It means that your sequence belong to, in this case, should be Clostridia, and provide detailed justification about your hypothesis. Do not overinterpret one of the justification. It means it belong to a monophyletic group. It should be also interesting to give the closest partner of your protein of your fragment. So if we go back on your tree, the closest partner, you have maybe 2 here, the 2 BFCCCO, FU, and so on. They are the 2 closest member of your organism. It's okay?
Yes. And
now, yeah.
And based on these 2, I will put a hypothesis of my RNA.
Yes, the hypothesis, your DNA your ORF comes from a DNA fragment. You agree with me?
Yes, yes.
And your DNA fragment comes from an organism. You agree with me?
Yes.
And that organism, the closest organism to your own organism, are those 2 ones, BFCCCO FU1 and BFCCCO F1E.
Yes.
Okay? That are the closest organism to your own organism, in fact.
So I need to specific to the genus or the species of these 2.
Yes, They belong to a species. If you have the real name, it should be useful to know from which one.
Okay, I understand.
Not BFCCC. It do not mean anything. In fact.
Yes. Yes.
Yeah. Okay.
Yes. That's all.
Okay.
Thank you.
I have someone in us. Yes, Tam wrote a life map from Lyon.
Actually, you call her Sao Mai,
Same.
not Mai, not Mai.
My.
Yes.
Okay. Yeah.
Okay, so I choose a in group is a
What is
bacterial.
it means you are it means you are working at the order level, right?
Yes, I work in the order level.
Okay. Your
My in group is bacterial then.
okay.
And my group is bacterial then.
Yeah. Why you
Yes.
why did you choose your out group as a single instead of Flavo?
Oh, I have tried the flavor, but
Okay.
the phylogeneity is not good enough.
And then I hope that you keep all of your tree.
I'm sorry, I have. Sorry.
In fact, for all of the students, you are making a scientific analysis, okay?
Yes.
And then you should have a proof of everything you are going to say in your analysis. If you just say, I choose Fango because I make a tree with Flavo and then I didn't get a good tree, it's not enough. You should have a proof of that. In science, it's everything like that. You should have results which confirm what you are talking about, so you should have the proof of that. It's okay for all of the students. It's really important, in fact. Otherwise, when you will submit your work for evaluation, and then we will talk you where are the proof of that. You cannot just tell us that it's working like that, and then we will accept. We are scientists, okay?
Yeah.
You are scientists. Yes. You are scientists. We are scientists, and then everything you should have a proof, a scientific proof. Okay.
Yes. Okay.
Mm-hmm.
So I first I choose because it have this have 19 results, so I can choose the outgroup of 10 from this.
Yes.
And this is enough for the in group because it has more than 100. And I think I choose it from the same film. So I think I can see whether it is come from the it has the same root or not.
No. Can you go back?
Yes.
Okay.
Yeah.
You told me at the beginning that you are working at the order level, right?
Yes.
So at the order level, if you choose Bacteroidetes as an in-group, you should find, this is from Bacteroidetes class on the left. Your outgroup should be in the same class.
Same class.
Same class.
Okay.
If you say, I'm working at the order level, your in-group and out-group should be in the same class, okay?
Okay.
Now, you can say, I'm working at the level of class. In that case, your in-group and out-group should be in the same phylum.
Okay.
You understand?
Yes.
Okay. So
because here in this case we have one class and one order, so can I move on the class?
Yes, you can move, but I can also tell you when you get your taxonomy classification using tax report and so on. Did you choose which level of tax report did you choose when you are using the tax report application? Did you click on 5 or 4 and so on?
Yes, I click
on 5 or 4.
I think on 5. I think after the order, because before when I click on the order, it didn't give the order. It only gives the class. So I click on, I think
on family.
Yes, yes.
And then can you go down? Can you go down a little bit? Where is your raw result about that?
My raw result is here.
Of tax report. Yes. So you see that in your raw result, you see that you have in the family level, Porphyromonadacea. You see on the family level?
Yes.
You can have Porphyro. You can also have Muribacculacea and so on. And if you go down a little bit, you go down. And then you have a lot of bacteria, Diacea and so on. It means that you can be able to get the origin of your fragment at that level.
Oh, so I will list more also the family.
You should do what?
I will list the classification of family in here.
Yes, it means that you should list the classification at the family level, and then maybe based on that, you will choose the in-group and the out-group.
Okay.
But they will be in the order of Bacteroides.
Okay.
Okay?
Okay. So I want to ask about the multiple alignment.
Okay. Yes.
Just about that, I'm at the class level because I do some alignment.
Okay.
I want to ask about this. How can I find the conservation of sequence within alignment reflect the subgroup?
So can you?
Yes, my alignment.
Okay. This is your multiple alignment. It's all?
Yes.
No. No.
It's quite long.
Okay.
My RF is much shorter than the other homolog, so it starts here.
Yes. But the question is, how can I be sure that there is a separation between in-group and out-group in my multiple alignment?
Yes.
So to find out, you should be able with your BBBBBB to distinguish with their mark what is in-group and what is out-group.
Yes.
And normally,
my out-group is here.
So as you can see, your out-group, all of them are together. Okay?
Yes.
So that's one way to know that they are grouped together compared to your in-group. But in-group also are grouped together, in fact.
Okay.
You see?
Yes.
Yeah.
So in the report, I can write that
yes.
They go together.
Yes, they are grouped together in your alignment.
Okay. I see. And for the length, because of the ORF is much more shorter than the other homolog.
Yes.
So is it affect the ability of is it a true homolog of the other sequence?
Yes, it's a true homolog. Yes, it's a true homolog. Don't worry about that.
Okay, because I think it's maybe because of the The algorithm of the applications of the OS is much more shorter than the other.
Yes, it doesn't matter. It's normal since you are working with metagenomic sequence. So due to the way that you break the DNA, you don't really know where you are breaking the DNA, so you can have partial or open reading frame in your fragment.
Okay.
Okay.
And on Mars other tree, I found a reference tree here.
Yes. Okay.
So my suppose that my in group is the bacteriocidia.
No. Can you go back? Here. Can you? Yes, that one. Okay. Is that one?
Yes, it has that color. And
yes. Yes.
My spigo has this color.
Okay.
So I want to ask, and I can see in the image, it was separate. Oh no, it's not clear here. I think this one. It has a lot of pictures in it. And here is yes, it's the order, yes, the color of the order that I choose, and the sphagnobacteria is here.
Yes, so they are separate.
So they are separate. So as I have my, I have my tree.
And your tree.
Is it separate? Follow the reference, right? Because my spingo is here and my bacteria is here.
Yes, it's separate too.
So I can conclude that they follow the reference trees.
Yes. So now from your tree, don't move. So can you stop moving the? No, don't move. Okay. Can you go down with your mouse? No, with only the mouse moving. Okay. You go on the left. On the left. You go a little bit down. And at that note, no. Yes. From that note, all of them are members of Svengo. It's okay?
Okay.
So now, if you go on the left, a little bit on the left, and then you go up, until the next note. And then from that note, all of them are members of Bacteroideia, right?
Okay.
So you have one big monophyletic group of bacteria, and then another big monophyletic group of Svengo.
Okay.
Okay? So you see that you have a clear separation between bacteria and Svengo.
Okay.
Okay? And this, it's really follow your life map tree or your reference tree.
Okay.
Okay.
So about the, I can see some question here is asked about the gene duplication and horizontal gene transfer. So I wonder how can I detect it when I look at the phylogeny tree?
Yes, it will be hard for you to detect gene duplication.
I have tried. I have read some article for instruction, but I'm not sure. That, like they said, here is one duplication.
No.
But I'm not sure it's
no. It cannot be. In fact, to find gene duplication, it means you have several copies of the same gene in the same organism. Okay? So from your tree, it's very hard to know if they are from the same organism or not.
Yes.
You see,
Yes.
it's hard to know if they are the same organism or not. So it's hard to find a duplication. But don't worry about that.
Oh, okay.
Mhm.
So we had to try to reply it in the report because it's one of the questions. So I want to
Yes,
try
but
to.
yes, all of the question you have, if you find them in the report, it's if you find them. If you don't find them, it doesn't matter. Once again, because you have in fact you have all you do not have the same tree. Students have completely different tree. Some of you, like you, will have a reference tree similar to the own trees. Some of you not, like with previous students. Some of you will have AGT, some of you not, and so on.
Okay. Okay. Thank you.
So in my OREF, I found 10 Indel and my OREF here you can see it's not belong to many in group. It's between the in group and the out group, and I don't know how to conclude whether they am homolog to my OREF or not.
There's nothing to conclude here. In fact, as you can see, your open reading frame is between your in-group and out-group, okay? And it's your, how to say that? To say that you have homologs, you already got the evidence for that. Remember, I mean, the question here is your question. Do I, based on my multiple alignment, can I conclude that my open reading frame is homologs to others? That is your question.
Yes.
So that question is not really, you cannot have those kind of question in your multiple alignment. That question, you already solve it when you are making your blast analysis to find your homologs.
Yeah.
So all of them here already are, all of the sequence on the left are homologs. Their position in your multiple alignment do not change the behavior as homologs. You understand what I mean?
No.
They already been homologs.
Yes. Okay.
If you choose them to build your homolog, to build your multiple alignment, it means they already been homologs.
Yes.
So you cannot use your multiple alignment to decide whether they are homologs or not. You understand?
Yes, I understand.
Okay. So
here, can you confirm that sequence are really homologs?
So can you confirm that? No, can you go on the top? Length doesn't matter. Can you confirm that they are really homologs? It means that are they really aligned or not? If they align, it means they are homologs. And then in your alignment, in your multiple alignment, I mean, your in-group or your out-group, sequence belong to in-group or sequence belong to out-group, should group together. This is a way to say that, yes, maybe they are really homologs. But it's you cannot decide if they are homologs based on your, you understand the difference? You just confirm
Yes, I understand.
If you build your multiple alignment and then you find that you have a lot of gap everywhere, it means maybe something is wrong about the way you choose your homologs. You understand?
Yes.
But if you build your multiple alignment and then you find, as in your case, that they really align, even you have some gap, but they align together from the beginning to the end, it came as a confirmation. You see, you confirm what you already feel about that. You confirm only the evidence you already have with last alignment. Yeah?
Yes.
It's okay? Yeah. Another question about your multiple alignment?
Well, I don't have any more. Thank you.
Okay, you're welcome.